Good morning. As you know, I am not here today. I'm on my way to the dentist, probably about this time. I don't know, or doing something else. Waiting to go to the dentist. Sorry, again, I can't be here. I'm going to go through a couple of things this morning, and then you'll have some time to work on stuff. On Tuesday, we started the normal distribution, which is like a bell curve where we have the mean in the middle, and then we can take the standard deviation and go out particular distances from that mean and get percentages of the data. So within one standard deviation on both sides, you're going to have 68-ish%. Two, you're going to have 95, and three, 99.7. We also need to remember that half of 68 is 34. Then when we go to the extra bits for two standard deviations between 1 and 2, 95 minus 68 is 27, half of which is on the high side, half of which is on the low side, 235, 235, and then we have that extra little bit at the end. So those numbers are going to come in really handy. Today I want to go over the first couple of questions from your homework. I'm also going to go steal one of my pictures so I don't have to try to make a horrific drawing of one of these later. So we did some examples on this, on percentages and all that. We're going to talk about this one, looking at a histogram and a frequency chart. So if I go down here, one of the questions I asked you to look at was this curling one. So I'm going to plot my distribution down here, and it tells us that the mean is 63, our standard deviation is 4. So if I'm labeling a curve, that's going to be the first thing we have to do for any of these. We put 63 here. And we go up a standard deviation, 67, up another standard deviation, 71, and 75. And we have to go down. 59. Minus 4 is 55, minus 4 is 51. In any of these questions like this, the first thing we need to do is label that. I'm going to cheat and use some straight lines. So we have our kind of bars in here. Just for fun, we'll change colors. And then although that one doesn't really show up all that well. And then all of that. So the first question asks, what percent is between 55 and 63. Well, we know that there's 68% here, or 34% in between there, and this one should be 13.5%. So 34 plus 13.5% is going to give us 47.5 or so percent. 67 to 75 is from there to there, which is the 13.5 again. And this one is to 35. (15.85%). Older than 75 it's hard to see on this particular image, but it's there. So we have to remember that it's outside of 99.7. So that's 0.3, half of which is 0.15%. So this is kind of your basic starting point for a normal distribution question. One super neat thing, I've got Desmos open over here. I'm going to actually open another one. Desmos has this wicked awesome function, because Desmos has all sorts of nifty things. Distribution, normal distribution, and that one, the question said the mean was 63. And the standard deviation was 4. So yeah, that looks like a flat line, but if we click over here and zoom fit, there we've got 63, and that's what the actual graph would look like. And there's that little itty bitty bit. And it also has this nifty thing, which we'll talk about a little bit more when we do Z-scores, which is going to be next week. So 55 to 63. So it will do 55, 63, and it's going to give you a percentage. Well, it's going to give you a decimal. 47 or 0.477 is the area there that's in red. If we make that a decimal, it's 47.7, which is close enough to what we're going to do here. We use the halves. They're technically approximate, but they do work out fairly well. So I'm actually going to use Desmos for the beginning of part number 2. So in this situation, we have 3 tests. One has, the first test is a mean of 77, a standard deviation of 3.9. Test number 2 is 83 and a standard deviation of 3.9. And test number 3 has the mean of 77 and standard deviation of 7.4. So what we should see if we graph these is these two have the same standard deviation, so they should have the same shape. They should have the same height. It's just one is slightly higher than the other, which is what we're going to see with 1 and 2. 1 and 3 have the same mean, so they're going to be in the same spot, but the one for number 3 that has the higher standard deviation is going to be not as tall and a little bit wider. So I have this over here. This is, the red one is 77 with a standard deviation of 3.9. And if we look at the graphs of the red and the blue one has the higher mean, so they're about the same shape fundamentally, but this one is just shifted. Whereas if we look at the blue and the green, they have the same mean, but like we figured, the green curve is the one that has the higher standard deviation, so it's more spread out, but it's going to be in the same location. So that's the idea behind that question. Oliver's mark on a given test is a great type of question. I just need to block this bit off because we don't really need it. So what we need to look at here is on test 1, Oliver has a mark of the mean which was 77 plus 2 standard deviations above that. So 2 times 3.9. So that's 77 plus 4 minus 8 minus 0.2 is 7.8. So that's what? 84 point. So that's, we can find what his mark is. Test 2 is the mean, which is not 77, is 83, minus 1 times 3.9, which is 83 minus 3.9, which is 79.1. So he did slightly, the average, they're not a whole lot different. Test number 3 is where he shone. Even though the mean was 77, he was 3 above the standard deviation. 3 times 7.4 is 21 plus 1.2 is 22.2. Preview 77 plus 22.2, so he would actually be 99.9. And a question I asked and thought about today is, on test number 1, it's not 99.9, on test number 1, is it possible or likely to have a mark of 99.2? That's something we can talk about, think of in that sense. So those were 2 of the questions. If you haven't finished the rest or the assignment, you need to work on those. But what I want to do is look at a question like this. So if we find these in our notes, let's give you a second. We have a bunch of data. We have the ages of grandparents in Elaine's classmates were collected. Does this approximate a normal curve? So how can we do that? Well, we can do a frequency chart, kind of look at a histogram. Hal's a new student. What is the likelihood that his grandparent is at least 80 years old? Well, we can look at some percents here in a sec. So 65 is going to be down here. I need to zoom out a little bit so I can see more of it. There we go. 85 is going to be here. 72. 65 again does those four because I'm going to try to keep better track. 70, 72, 64, 74, because I messed this up on Wednesday. 60, 82, 81, 69, 74, 74, 71, 71, 71, 61, 90, 70, should give me to there. Hopefully this adds up. 75, 75, 71, 76, 56, 83, 78, 80, 68, 62, 73 goes here, and 69 goes there. Here's hoping. 1, 4, 5, 12, 4, 4, 1, 1, 5, 10, 20, 32. Yes, I got it right this time. So, does it approximate a normal curve? Well, a normal curve should start low, go up, and come down, kind of like that. So this starts low, then goes up, and comes down. So we can look at this, and I'll post this particular set of data. Here's all of the ages. I want to insert a histogram. I can do this. I don't like those, so we're going to try to get the right thing. Format chart area. Horizontal axis. So what did we have? 1, 2, 3, 8 pins. Pin width of 5. Let's say, I want to do this one. What do we have? Less than 60. So, less than 60. And this does it slightly differently, but it goes up and goes down. So it, and for whatever reason, it's not picking up those. 2, 5, 10. So this does things a little bit differently. Does it approximate a normal curve? Yeah, I would say so. I did a histogram, it looks kind of like that. So what is the likelihood that someone is above 80? Well, we've got 4, 5, 6 out of 32. I'm going to go over here just because I've got all of this. Calculate the mean, like we've done a number of times. Say, okay, so the mean is 72.1. And the standard deviation, the two things that we're going to use the most. Is 7.5, 7.4. So if I go back to here, the mean in the middle is 72.1, 79.5. So one standard deviation is 79.5. So Above that, we've got 13.5 to 35 and that. So what is the likelihood there? Over 80, 13, 14, 15. So there's about a 16% chance because it's all of this stuff that's over there. So what we're going to do is I'm going to post some of the questions at the end with data sets so you can find the mean, the standard deviation, and answer a couple of those. If you haven't finished the ones that you were supposed to be doing on Wednesday, you can work on those. And if not, the assignment. So that's where I'm going to stop. If you have questions, we'll discuss them on Monday. Have a great weekend, and we'll see you on Monday. Bye.